In this lesson for indices and surds, we're going to look at simplifying complex expressions. So in other words, what we're going to be dealing with exam questions. And sometimes in these exam questions it is necessary to simplify complex surd expressions involving several terms. The key to these examples essentially is to break the problem into stages and simplify one term at a time. Once each individual term has been simplified, we can then return to the whole expression and consider whether the simplified terms can be simplified even further. Here we have a typical example that looks like an exam question. Simplify fully root 6 times root 30 minus 15 over root 5 minus root 140 over root 7. Okay, so let's have a look at how we approach this. I'm going to break this into three stages because there is one. I use different colours just to highlight this. This is 2, and this is 3 terms. Okay, so I wouldn't usually do things in different coloured pens, but just to highlight this, I'm going to show you how this works. So in the black, root 6 times root 30. If I multiply this together, I get root 180. Now, simplifying this surd, couldn't really simplify 30, there's no square factors. Couldn't really simplify root 6, there was no square factors. So I had to multiply this out. Looking for square factors of 180. 9 is a square factor, but it's not the highest square factor. In fact, 36 is the highest square factor. So if I do root 36 times root 5, and then I can simplify this. Square root of 36 is 6, so I get 6 root 5. And we've dealt with the first term. We then look at dealing with the second term. So 15 over root 5. In this expression, all I can do is rationalise it. So don't worry about the whole simplification process. The questions are constructed so you can simplify as much as possible. You just think about how would you simplify the individual terms. And generally speaking, if we've got a root on the denominator, what we want to do is we want to rationalise. So I get 15 times root 5 over root 5 times root 5, which is 5. And then I can divide top and bottom. Let's just make this a little bit clearer. Let's start that expression again, make it a little bit clearer. Okay, so we should have had 15 root 5 over 5. So dividing top and bottom by 5, I get 3 root 5. Finally, again, not paying any attention to the whole expression as a whole, just want to worry about the individual terms. I've got root 140 over root 7. Now initially, if we've got a denominator on that is irrational, so if I've got a surd on the bottom of the fraction, I'm looking to rationalise. So I'm generally thinking, okay, well let's multiply top and bottom by root 7, but multiplying root 140 by root 7 isn't going to be simple, and then even more so, simplifying the result is not going to be simple. So what I do here is actually I notice that 7 is a factor of 140, so I'm going to simplify it this way and I'll say, okay, well root 140 is the same as root 7 times root 20. And this is over root 7. And so what I get left with is root 20. Now, we may be tempted to think at this point in time that, okay, well, I've finished simplifying, but really, if we look at our surds, notice this is root 5, this is root 5. So I'm hoping perhaps, because I want to simplify this whole expression, that this is going to come out in terms of root 5 as well. And what you're going to notice is that this has a square factor of 4. So root 20 is in fact root 4 times root 5. And now it makes sense because it matches up with the other two terms. So just simplifying fully, square root of 4 is 2, and I get 2 root 5. And what will happen, generally speaking in an exam question, it's not guaranteed, but what will happen is that generally the terms will simplify to some multiple of the same surd so that they can all be collected and reduced into one term. It's not all the time, it's not a hard and fast rule, but you can use it to guide yourself to, because you should be getting fairly simple expressions. Now, what we can say, writing this out in the end, is that, root 6 times root 30 minus 15 over root 5 minus root 40, 140, sorry, over root 7 is equal to, well, root 6 times root 30 was 6 root 5 minus 15 over root 5 was 3 root 5 minus root 140 over root 7 is 2 root 5. And so now I'm just collecting terms, because I've got 6 root 5, take away 3 root 5, which is 3 root 5. Take away another 2 root 5, just gives me an answer of root 5. And if you're a little bit thrown on still with the idea of collecting terms, just remember what we're actually saying here is this is the same as 6y minus 3y minus 2y, which would be equal to y. The fact that I'm collecting surds here doesn't make any difference. It's dealt with exactly the same as any other algebraic problem. Okay, well, I hope that all made sense and that you was able to follow my solution.